Hello and welcome. In this video we are using Python and some optimization techniques to answer the question, what is the set of indicator values yielding the maximum profit of a trading strategy? We are starting with a one parameter strategy, which is simply we are buying when the price is above the simple moving average and selling when the price is below the SMA. So the only parameter to optimize is the SMA. Then we are moving on to a two parameter case, which is we are buying when the first SMA is above the second SMA and selling vice versa. Before we are getting into the code, I want to share one important concept you need to conceptually understand, which is the Cartesian product. So the Cartesian product is important when you need to find the combination of all parameters in an optimization. So take this table here as an example. You have x and y and 1 and 2. And the Cartesian product now is simply all combinations of those. So in this case, 4 combinations. If you have 3 each, it would be 9 combinations and so on. You will see that this scales pretty fast when taking an array of SMA values in the video. Important disclaimer, concepts shown in this video are not an investment advice. Video is for educational and entertainment purposes only. Alright, let's get started. We need some libraries. While Finance supports stock price data from the internet and Pandas and NumPy for data handling. Next, I'm going to download price data for Apple. Just an example, you can analyze whatever stock you're interested in. And I'm starting my analysis in the beginning of 2010. With that, I'm getting daily open, high, low, close data. First thing I'm going to do is to create a new column storing the buy or sell price. And the buy or sell price is simply the open column shifted one row back. Why? Imagine you're getting a buying or selling signal in this row. You cannot buy or sell on the close. You can only buy or sell on the next trading days open. When I shift it, I have the buy or sell price in the same row as the potential signal, right? So as said, I'm creating a new column, price, that could be the buy or sell price, and that is simply my open shifted one row back. So this is how it looks like. So you see, this is the next day's open. So this is this value here, this is next day's open, this is this value here, and so on. Next, we need a function which is calculating a flexible simple moving average for us. So I'm going to call that function macalc, and this is taking an n, which is the rolling window. So if I provide a 10 here, I'm getting the 10-day simple moving average, 20-day simple moving average. You got the point. And this function is adding a column to this data frame and is rolling over the close with the provided rolling window and then takes the mean. So if I would call this function for the 10-day simple moving average and then print out the data frame, you see that I have a new column here containing the 10-day simple moving average. If I change that, so if I call that on 20 and print out the data frame again, you will see that the values are slightly changing as they contain the 20-day simple moving average now. Now let's get to backtesting. So what do we need to do in general? We need to loop over this data frame and check if the close is above the simple moving average. Whenever that is the case, we are buying, and when the close is below the simple moving average, we are selling. As I explained in the beginning, a very simple strategy. So I'm going to set up a function which is doing the whole backtest for us. So let's call that backtest, taking our data frame and a rolling window, because this is simply the variable taking care of the provided rolling window you're testing. So this function should return you the overall profit of a, let's say, 10-day simple moving average strategy. It should also give you the return of a 20-day simple moving average strategy, 50-day, 60-day, and so on. right? So we have a provided rolling window here, and within this function, the first thing we are going to do is to call our MACalc function on the provided window. Why? Because this is doing the data manipulation to our data frame, and with that we have the SMA value for the given rolling window. And then we can loop over this data frame. Before starting the loop, I want to set my position flag to false, because initially we are not in a position. And this is changing once we're getting into a position, which you will see in some seconds. Also, I want to store the profits generated from the strategy. So when I bought, some when I sell, right? And in my profits list, I want to store the relative profit. That is simply sell price minus buy price in relation to the buy price. Okay? And now we are looping over this data frame. So we are looping for index row in df iteros. And first of all, we are checking if we are in a position, or rather if we are not in a position, because we are applying the buying logic first. So if we are not in a position, if not in position, which is initially the case, right? Then we are checking the buying logic. Is my close above my SMA value? And as said before, this SMA value is dependent on the given rolling window, right? This is what this part of the function is taking care of. And when this is the case, I want to store my buy price. And this is simply my price, right? And again, my price is my next day's open. So if my buy price stored, I know for what price I bought Apple in that case. And then I'm setting my position flag to true, because now I'm in a position. Now let's go to the selling logic. If I'm in a position, I want to check, is my close below the simple moving average? If that's the case, I want to calculate my profit. And my profit, as I just explained, is my sell price, which is the current price whenever this is happening, minus my stored buy price, which is the price I bought the asset for, in relation to my buy price, the relative profit of that trade. I'm going to store that in profit and then append it to my profits list. And of course set the position flag to false now, as I sold and I'm not in a position anymore. Now when I run this loop, I populate this profits list, right, and get all trades. I'm not really interested in all the single trades. I'm interested in the overall profit of the strategy. So I have to accumulate the elements in this profits list. So I'm going to call that gain. You can also call that overall profit, or whatever you think makes the most sense for you. Then I'm doing a Panda series transformation of the Python list and take the profit. That is simply accumulating the returns in the profits list. I've explained how you accumulate returns in another video, which I will link in the video description. So I'm doing the series transformation of my profits list, add a 1 and take the product. With that, I have my overall gain or my overall profit of this strategy. And this is exactly what I want to return. Okay, so let's save some space here. That should be fine, or that is fine. Now, what does this tell me? If I apply that on my data frame and provide a 10 window here, I'm getting the profit of a 10-day moving average strategy. So I'm buying when the close is above the 10-day moving average, and I'm selling when my close is below the 10-day moving average. If I would do that on Apple since 2010, I would get a profit of, this is 8x, right? So this is, you would have to subtract 1 here and multiply it with 100 to see the percentage profit here, right? So for now, this just 8x your capital. Sounds great, right? But now let's take a look at the Apple price development. So we could just take the close, then take a look at the percentage change, getting the daily profits, and accumulate them as well to get the development of the Apple stock. You see that you have a 19x here of Apple since 2010, right? So yeah, this is not outperforming the Apple stock at all. By the way, just as a side note, what you can also do is just take the close, the most recent close, and set it into relation to the close on the first trading day, and you see that this is the same number, right? It's just the exact calculation. This is accumulating the profits, and this is comparing the price with the first price. Same result. Anyhow, this would be the return for the 10-day strategy. You can pass now. 20-day strategy is 14x, 30-day strategy 9x, and so on. Now let's get to the optimization part. Now it's obvious what you have to do, right? You just pass parameters to this function. Now to get a range of parameters, we can utilize the very handy range function from NumPy. And this is creating an array of values, starting from a particular value, going until a particular value. So if I take 10 until 205 with a five steps, so this is simply the step size, I would get an array 10, 15, 20, and so on until 200 here, which is quite nice because I just have to loop over this range or this array now and can pass it to my function, and with that I already ran the optimization or analyzed what would be the best simple moving average window for this simplified strategy. So let's do that for n in this NumPy range here. Then just call this function. So print backtest for n. And we also want to see which parameter we passed. So we're just printing out the n here and run this. So for parameter 10, 8x, 14x for 20. Here we even have 16 something for 165 and so on, right? But interestingly, this also shows that whatever parameter you're passing here, you're not outperforming the asset itself. So this strategy is not enough. So I want to save some time. What you can also do is store these profits in a list, then make some visualizations here and actually find the minimum of the list, and then you have the actual optimization, right? But I'm not doing that step. You can do that for yourself. It's simply finding the minimum of a list. Okay, so this is for one parameter, right? Now let's move over to 2-parameter optimization, which is slightly more challenging. So first of all, what do we need to change? We need to change our moving average calculation function first. Why? Because the second strategy is my fast simple moving average, or let's just take my first simple moving average is above my second simple moving average, right? This is the second strategy. So we need n and m. So n is the window of the first, and m is the window of the second simple moving average. And then we have to make this change here, so this stays the same. And then we need the same for the second simple moving average. Here, right? So this is our MA calculation now. So how this is working, if I want to have the SMA1 and SMA2, first one as 10-day and second one as 20-day, I'm executing this function, and now I have an SMA1 and SMA2 value in my data frame, right? So what I just need to change here is to add a new parameter, then provide the new parameter as well, and slightly change my backtesting logic here, right? So what do I need to change? Instead of closes above the SMA, I'm simply checking is my first SMA above my second SMA, and for this one is my first SMA below my second SMA, right? Still a very simple strategy, but I think you get the point of this here, right? Rest basically stays the same, so same profit calculation, and let's execute that. And now you have to pass those two parameters. So if I take 10 and 20, I'm getting the return of a strategy where the 10-day moving average is above the 20-day moving average. So here I'm buying and I'm selling when the 10-day moving average is below the 20-day moving average. So this would be the return of that. And now it's getting really interesting, at least in my opinion. Now what do we have to do? We cannot just pass one array of parameters, we need two arrays. The tricky thing now is we need all combinations here, right? So we basically need two arrays. Let me show you what I'm talking about. Basically need two arrays, and we need the 10 for the first one combined with all those values here, right? We need the 15 combined with all those values here. This is called, so in mathematical terms, this is called to find the Cartesian product. So how can we do that? Or in database terms, you find the cross product, or you are cross joining those two arrays here. So how can you do that? I'm just storing the first array in X, second array in Y, just to have them stored somewhere. And then just calling that final, use pandas merge function, provide X and Y, and then I'm picking a cross join here. And with that, we're getting an error. Excuse me, you have to transform that to a data frame first. So I'm just transforming this NumPy array to a data frame, execute that again, and now it will work. So now you see I'm getting 1.5k rows here. I'm getting all combinations, right? 1010, 1015, 1020, 1025, and so on. And this is how the Cartesian product or cross join would work, right? And with that we have all possible combinations, and we can simply pass these parameters to our backtesting function. That's pretty nice. Before doing so, I just want to do some simple manipulations here. So the column names should be SMA1 and SMA2. And also very important here, we have rows where we have the same values. So that doesn't make any sense, right? So we only want to test different values here. So I'm just excluding those rows which have the same values. So I'm simply checking SMA1 is not SMA2 and screen for them. So with that, you see I only have different rolling windows here. Reassigning final to that. And now we are looping for n, because we have two parameters. And then we can just take final values. So final values is looking like this. You have the first, which is simply the SMA1, and the second, which is the SMA2. So if you loop for n, in final values and print out and then you will get it like so, right? So you have all combinations here. So res is straightforward, right? You want to have backtests of n and m, and you also want to print out the m parameter as well. So let's go. So we have 10, 15, we have 8, 10, 20, we have 13. And now, same as before, you can create a list now and find the optimal value here, so the maximum of the list. I think I said minimum before. That's of course wrong. You want to find the maximize profit, right? So what do we see here on first sight? Yeah, until now I didn't saw that Apple was outperformed here, right? And as you see, even if you do a dedicated optimization here, you see that this strategy is not enough to outperform the Apple stock, right? And yeah, there's much more to that, right? So for instance, optimize on a training set and check if it is performing on a testing set, and many more stuff, right? Not only 2 parameters, but 3 parameters, adding more complexity to that. But I think for now, this is quite interesting. So if you are interested in deep dive or continuation of that, let me know in the comments below. I thank you very much for watching, and I'm looking forward to see you in the upcoming videos. Bye bye.